guys, welcome back. So in this video, we're going to go over some of the graphing problems from the practice problems and talking about transformations and creating equations given transformations. So let me turn on my document camera and then we will get started. Okay. All right. So number one, it's not in Vertex form. So there are a couple ways you can do it. You can use your negative b over 2a to find the x value for your vertex, plug it in, get your y value. There's your vertex, your axis of symmetry, all of that. So the first four, just the first one is like that. So I'll show you. No, I won't. I was going to say I'll show you how to convert this one, but this isn't an easy one to convert. So what we're going to do is our negative b over 2a. So this is standard form, right? We're in standard form here. Or you could actually, now that I think about it, you could look at this as your a value is -1. If it's just x squared and it's not like x plus or minus anything squared, like it's not x minus h squared, that means your h is 0. All right. And your k value is -3. So our axis of symmetry is x equals 0. So it's on your y-axis. That's your axis of symmetry. Your vertex is going to be 0, -3, right? Your HK. Let's graph the vertex. So 0, -3. So 0, -3 is your vertex. And then 1, 2, -1, -2. So if x is 1, we have the opposite of 1 squared -3, or -1 minus 3, which is -4. So at 1, I go down to 3, 4. And 2, this would also be -4. And at 2, I have the opposite of 2 squared -3. So the opposite of 4, which is -4, minus 3, which is -7. So 4, 5, 6, 7, and reflect here. And here's your graph. Okay, so A was negative, so therefore we have a maximum value, right, at -3. Our parabola opened down, so it was never going to cross the x-axis. So my roots were not real, right? They're imaginary roots. My domain is all real numbers. My range is y is less than or equal to -3. My transformations were the graph was reflected over the x-axis and was shifted down 3 units. Alrighty. So that's it. So let's look at number 2. So here we have y equals the quantity of x plus 5 squared. So my a value is 1. My h value is -5 because it says plus 5. And my k value is 0. So my axis of symmetry is x is equal to -5. So let's put that in. A is positive, so my graph is going to open up. It's 1, so it's not stretched or compressed. It's like the parent function. So my vertex is at -5, 0. So this graph has one root because your vertex sits right on your x-axis. So even if you were to solve this, you're only going to get one root, and it's going to be -5. So solving it's not going to help you. So let's use our vertex at -5, 0, and let's pick our values. So -4, -3, -6, -7. So I'm going to use my easier numbers, my smaller numbers. So y is equal to -4 plus 5 quantity squared. -4 plus 5 is 1. 1 squared is 1. So at -4, I'm going up 1. And at -6, I'm going up 1. And then at -3, -3 plus 5 quantity squared. -3 plus 5 is +2. 2 squared is 4. So at -3, I go 1, 2, 3, 4, and that's reflected to here. And here's your parabola. All right, so our vertex was at -5, 0. Our domain is all real numbers. The range is y is greater than or equal to 0. The transformations, my a was 1, and it was positive, so that it was not stretched, it was not compressed, it was not reflected. So you don't need to say everything that it's not. I'm just going through that with you. So the only transformation that happened from this parent function was a translation left 5 units. That's it. Okay. All right, so let's look at number 3. Let's look at number 3. So our a value is 1. Our h value is +2, right? Because So even though it says -2, that minus sign is in your original equation. So therefore it's a +2. And And our k value is -6. So our axis of symmetry is at x is equal to 2. So let's put that in. Okay, our vertex is at 2, -6. So let's plot that. So 2, -6. So our a value is 1. So that means it's going to open up. So I will cross my x-axis. I'm not going to use my discriminant because I would have to change this into standard form and then do the b squared minus 4ac. So I'm just going to solve it. And I already know just by looking at it that my roots are going to be irrational, and I'll tell you why. So if we have x minus 2 squared minus 6, and I want to solve that, I set it equal to 0, right? So then I can add 6 to both sides. So then I have x minus 2 squared equals 6. So if I were to expand out that x minus 2, I'd get x squared, minus 4x plus 4 equals 6. I don't know what I was thinking. I don't know why I moved the 6 over. So then I have x squared minus 4x minus 2 equals 0. Yeah, I was right. Okay, sorry. I'm having a fight in my head. You know how I always do that when I second guess myself and then, okay. So I'll take you through this with the quadratic formula and then I'll show you what I was thinking earlier. Okay, so, oh, lordy. So negative b plus or minus the square root of b squared minus 4 times 1 times -2 over 2. So 4 times 2 is 8, so 16 plus 8 is 24. So 4 plus or minus the square root of 24 over 2. So square root of 24 is not perfect. So here's my irrational roots. So what I was going to say, what I was going to say was if I just did x minus 2 quantities squared minus 6 equals 0, if I add a 6 to both sides, I have x minus 2 squared equals 6, right? The square root of 6 is not perfect. So therefore, I'd have x is equal to 2 plus or minus radical 6. Because 4 plus or minus radical 24 over 2, right? When I use the quadratic formula, if I were to simplify the square root of 24, well, 24 is 4 times 6, right? So if I take the square root of 4 out, I get 4 plus or minus 2 radical 6 divided by 2. And then this is a mistake a lot of you made when you were solving, was you're simplifying. So see how this is separated by a plus or a minus? They both have to be factors of the denominator, or the denominator and the coefficient and the 4 all have to have the same factors, right? So I can divide each one by 2. So that's going to cancel. So you get 2 plus or minus 2 divided by 2 is 1, radical 6. So I just used the square root method in my head to solve that one. And then I second guessed myself and didn't believe myself. And I shouldn't have done that because I was right the first time. But anyway, it was a nice segue to show you something. So if you can see just by moving this term over, and if there's a coefficient here, you would have to divide. If you get a perfect square, then you're going to have roots that you can graph. Okay? So hopefully that didn't confuse you. It probably did, and I apologize. So 2 and negative 6. So now I'm going to substitute in 1, 0, 3, 4. So now I'm going to substitute in a 1. So 1 minus 2 is negative 1. Negative 1 squared is 1. 1 minus 6 is negative 5. That's going to be reflected over your axis. So 1, negative 5, reflect it, negative 5. And now I'm going to plug in a 0. 0 minus 2 is negative 2. Negative 2 squared is 4. 4 minus 6 is negative 2. So then 0, 1, 2. And reflected. So there you go. Here's your parabola. So our domain, all real numbers. The range, y is greater than or equal to negative 6. The transformations, this was not stretched, this was not compressed, this was not reflected, so I don't have to write any of that. But this was translated 2 units right and 6 units down. Okay. All right, I'm not going to do number 4, but I am going to do number 6. I'm not going to do number 5 either, but I will do number 6. So number 6, our axis of symmetry is at x equals, so first our a is negative 2, our h is negative 3, and our k is 7. So our axis of symmetry is at x is equal to negative 3. And my vertex is at negative 3, 7. So let's put in negative 3, 1, 2, 3. And let's put our vertex in. Okay, so this was reflected over the x-axis. So because my a is negative. So that means it's going to open down. So I want to see if I'm going to have roots that are going to be integers that I could graph. So if I do negative 2, x plus 3 squared plus 7 equals 0, if I move the 7 over, negative 2x plus 3 squared equals negative 7 divided by negative 2. Then I get x plus 3 squared equals 7 halves. So if I were to take the square root of 7 halves in order to solve, I'm going to have an irrational number. So that means my roots are also irrational. So I'm not going to try to solve this any further because it's not going to help me graph. So what I am going to do is put in my vertex, which is negative 3, 7. And then I'm going to go -2, negative, oops. Yeah, I guess it doesn't matter which way we go, right? It doesn't really matter. Okay, so -1, if I substitute in a -1 plus 3 is 2. 2 squared is 4. Now 4 times -2 is 8. And then -8 plus 7 is -1. So at -1, I'm at -1. And if I reflect that over here, I know I should have done -5, -4 up top, but I'm sorry, it's getting late. Okay, so now I can substitute a -2. So -2 plus 3 is +1. 1 squared is 1. 1 times -2 is -2. -2 plus 7 is -5, +5. So -2, 1, 2, 3, 4, 5. Okay, so here's your parabola. Okay, so my domain is all real numbers. My range is y is less than or equal to 7. And my transformations, this was reflected over the x-axis. It was translated 3 units left and 7 units up. And this was stretched by a factor of 2. Okay? Whew. All right. So let's talk about how I would write. I'm going to do a couple of these. So how would I write the function given these transformations? So remember, the parent function is y equals x squared. So if I'm reflected over the x-axis, that means my a value is negative. It doesn't talk about being stretched or compressed, so my a value is -1. It's translated 6 units to the left, so my h value, because left or right is going to be your h value, so my h value is going to be -6. It doesn't talk about a vertical one, a vertical translation, so my k is 0. So what is that going to look like? That will look like, you can use f of x or y. Y is equal to negative x minus h is -6 squared, and then plus 0. So I did this because I wanted to show you if it's translated 6 units left, that's negative, right? But we have minus a negative, and that makes it x plus 6. So y is equal to negative x plus 6 quantity squared. That is your function. Okay. Let's look at 12. So vertically stretched by a factor of 3, then translated 4 units up. So if it's vertically stretched by a factor of 3, that's your a value. So a is 3, and it's translated 4 units up. That's your k value. And it doesn't talk about a horizontal shift, so h is 0. So we would say y is equal to 3x squared plus 4. Because if h is 0, you get x plus 0 quantity squared, and your a is 3, so it looks like that, but x plus 0 is just x, so that's where the 3x squared came from. So yeah, okay? All right, so hopefully that makes more sense to you now. Or if you were just here to see if you got your answers right, hopefully you got your answers right. All right, guys, you know where you can find me if you have any questions. I shall see you all soon. All right, bye, guys.